the product rule for derivatives. Let y be a product of functions f of x times g of x. Then the derivative of y is not f prime times g prime, but f prime times g of x plus f of x times g prime of x. So you will hear me say when I do product rule and other rules that I do the derivatives by position, not necessarily by formula. Before we get to some examples, let's look at a proof of the product rule. This doesn't necessarily add insight when you're first learning calculus, so feel free to fast forward through the proof if you would like. But for those who would like to see the proof, I'm going to go through it. So to prove a derivative rule, we need to go back and use the definition of the derivative, which is the following. It is the limit as h goes to 0 of y of x plus h, so f of x plus h times g of x plus h, minus y, or f of x times g of x, all over h. That's the definition of the derivative. Now we're going to do a step that you might not have seen before, but it's kind of a good thing to know in mathematics. It's somewhat typical when you go forward and when you start proving things. But we're going to do the following. We're going to let the limit as h goes to 0. I'm going to rewrite f of x plus h times g of x plus h. And then I'm going to subtract something. Let's subtract f of x times g of x plus h. I have changed the expression, so I'm going to need to re-add that back. Plus f of x times g of x plus h. And then minus the original f of x times g of x. So what I did here was I added 0, which means I have not changed the expression, so I'm allowed to do that. And then, of course, everything over h. Now, I'm going to do a little algebra on the side, kind of a basic algebra. If I have something like this, 4 plus 2 over 2, I can rewrite that as 4 over 2 plus 2 over 2. So you're going to see that I'm going to break up this into two separate pieces. The first two parts and the second two parts, which means, if you look at my algebra down here, I can put an h over both. And then let's rewrite this again. For the first part, I'm going to factor out a g of x plus h. So that gives me f of x plus h minus f of x times g of x plus h. Time for a little side algebra again. I'll do it slightly above. If I have 4 times 3 over 2, I can write that as 4 over 2 times 3, not times 3 over 2. Or I can write that as 4 times 3 over 2. That is, I can put the denominator under either the top factors. So I will put the h under the first part. Now let's look at this back piece here. They both have f of x. So I will factor out the f of x from them. And that'll leave me with g of x plus h minus g of x. And then I choose to put the h, because it's a product now, I choose to put the h under the back part. How does this help me? Well, let's take a look. This part right here, as h goes to 0, is f prime of x by definition. This part here, as h goes to 0, is g of x, because it's g of x plus 0, essentially. And then plus f of x right here. And then this piece here, as h goes to 0, is the definition of g prime of x. And that's where the product rule comes from. But let's take a look at some examples, starting with algebraic examples. So find the derivative of a product, x times cosine of x. So I get asked this question a lot. Should I do the product rule? And my answer back to my students is usually, do you have a product? Now, if it's a numbered times a function, I wouldn't do the product rule. But if I have like x's times x's, I'm going to do the product rule, generally speaking. So how do I take the derivative? Again, as mentioned before, I do it by position, like this. Let's take the derivative of the first piece and leave the second part alone. Plus, leave the first part alone, times the derivative of the second part. And I will rewrite this to clean it up a bit. You don't necessarily need to, but I will here. And we get the derivative of f. Another algebraic example, which is a product. G of x equals x squared times root x plus 1. So, product rule says take the derivative of the first part, leaving the second part alone, plus leave the first part alone, times the derivative of the second part. And there is a way to put those two pieces together by getting a common denominator, but I will leave it as that. One more algebraic example, which again is a product. So h of x is x cubed minus 3x squared times tan x. The derivative is the derivative of the first part, 3x squared minus 6x, leaving the second part alone, plus leave the first part alone, times the derivative of the second part. I will pause to let the ambulance pass by. Now let's do a numeric example. Consider f of x and g of x to be continuously differentiable functions for all x. Note, differentiable means the derivative exists. I have some values stored in my table. Let's start by finding the derivative of f times g at x equals 2, and then use that to help us write the equation of the tangent line to y equals f times g at x equals 2. So part A, the derivative of f times g is, well, it's the derivative of the first part at 2, leaving the second part alone, plus leave the first part alone, times the derivative of the second part. And now all we have to do is just plug in. F prime of 2 is negative 1. G of 2 is 4. F of 2 is negative 3. G prime of 2 is 2/3. And we can clean this up a bit. We get negative 4 minus 2 equals negative 6. So there's the slope of the tangent line. The derivative is not the equation. It is the slope of the tangent line. I have my slope. I'll call it m over here. I have my x value, which means I'm missing my y value. But y is f times g, so y at 2 is f of 2 times g of 2, which is negative 3 times 4, which is negative 12. So I have the point 2 comma negative 12. The slope is negative 6. And the tangent line equation is y minus the y value equals the slope times x minus the x value. One final problem. Let f of x be the graph, which is composed of two line segments, and let g of x equal 2x squared minus 4x cubed. Write the equation of the tangent line to y equals f times g at x equals -2. Well, we have the x value. Let's get the y value now. Y is f of -2 times g of -2. Which is, well, f of -2 is 1. And then g of -2 is 2 times -2 squared, or positive 4, minus 4 times -2 cubed. So we get 1 times 8 plus 32, or 40. We have the point now. Now we need the slope. So the derivative of y, which is a product, is going to be derivative of the first part, leaving the second part alone, plus leave the first part alone times the derivative of the second part. F prime of -2, we could find it by getting the equation of this line segment here. But since the derivative is a slope, let's just find the slope of this line, which is up 2 over 4, or 1/2. We already found g of -2, 40. We found f of -2, which is 1. So the only thing we're missing is g prime of -2. Let's find g prime of x first, which is 4x minus 12x squared. And then g prime at -2 is -8 minus 12 times -2 squared, or 4. Simplifying that, we get -56. So the slope is 20 minus 56, or -36. We now have the pieces we need to write the equation of the tangent line. And we get y minus the y value equals the slope times x minus the x value.